In this video, we're going to take a look at the graph of the cosine function. Again, this is the very basic graph of what the cosine function would look like. Okay, so again, the function we would write y equals the cosine of x, where x is our input and is actually an angle measure. You could also see it written, again, remember that you can write this same thing as f of x equals the cosine of x. We learned earlier in algebra that y and f of x represent the same thing. And again, we're thinking about x, and the input is a angle measure from the unit circle in radians, which it typically is when you're looking at the two-dimensional graph of the cosine function. And if you'll recall, the cosine of the angle corresponds to the x coordinate of that point. So again, if you think about it, if we look at x equals 0, so if I wanted to look at the cosine of 0, I would find that angle measure on the unit circle and look at the x coordinate, which is 1. So the cosine of 0 is 1. Okay, then we continue the rotation. Cosine of pi sixth, again, we would look for the angle measure of pi sixth and then look at the x coordinate, which is the square root of 3 over 2. Continuing that rotation, if we look at the cosine of pi fourths, we have the square root of 2 over 2. For pi thirds, the cosine is 1/2. And at the quadrantial angle of pi halves, the cosine of pi halves equals 0, because the x coordinate for the angle pi halves is 0. Okay, so that happens to be, since it equals 0, that's one of our zeros or x intercepts. Let's see, then we keep rotating. 2 pi thirds would be negative 1/2. I'm now in the second quadrant. 3 pi fourths is negative square root 2 over 2. Again, you're simply reading the x coordinate of the ordered pair that corresponds to that angle. So cosine of 5 pi sixth is negative square root 3 over 2. The cosine of pi, which is another quadrantial angle, is negative 1. Again, notice the high point or the maximum is 1 and the minimum is negative 1. Again, because those are the points, the unit circle only has a radius of 1. So we go 1 positive and 1 negative. So then sine of 7 pi sixth, you would have negative square root 3 over 2. Cosine of 5 pi fourths is negative square root 2 over 2. Cosine of 4 pi thirds is negative 1/2. Again, reading the unit circle. Cosine of the quadrantial angle 3 pi halves. At 3 pi halves, it's 0. So again, I have a 0 or an x-intercept at 3 pi halves. Continuing the rotation, cosine of 5 pi thirds would be positive 1/2. Cosine of 7 pi fourths is square root 2 over 2. Cosine of 11 pi sixths is square root 3 over 2. And then we're back around to the full revolution, and the cosine of 2 pi is 1, which again is our maximum point. So really the only value that we haven't really identified here is our y-intercept. And remember, the y-intercept occurs where it crosses the y-axis and your x value is 0. So I actually have the y-intercept occurs at 0, 1, which happens to also be one of our maximum values. And again, I've pointed out the maximums and the zeros and that kind of thing because those are the points that we tend to focus on when we are graphing the cosine function or any function. You want to focus on those key points: your y-intercept, your zeros, your minimum values, and your maximum values. And again, typically for the cosine, similar to the sine, those values occur at the quadrantial angles. So if we create this graph by hand again, I begin by drawing my coordinate grid. Okay, I'm going to kind of center it. So you have your vertical number line, which is your y-axis. You have your horizontal number line, which is your x-axis. Again, vertically on the y-axis, we oscillate or rotate between a maximum of 1 and a minimum of -1. Again, we're going to focus on the quadrantial angles, so we have 0, pi halves, pi, 3 pi halves, or 2 pi. Now here again, we can also rotate negatively. So I would have negative pi halves, negative pi, negative 3 pi halves, and again, negative 2 pi. So if we go back to the table and we start looking at our ordered pairs, when x is 0, y is 1. So I have the ordered pair 0, 1. Then looking at the next quadrantial angle, when x is pi halves, y is 0. Okay. So I have pi halves, 0. At pi, we had a value of -1. You can double check the table. 3 pi halves, it was 0 again. And then at 2 pi, we were back at 1. And then if you connect the dots with a smooth curve, you basically get this curve here. Okay, so that's the basic cosine curve. Again, notice with cosine, it begins and ends at your maximum of 1. Halfway, it's at your minimum, and you have zeros in the other spot. So it's maximum, 0, minimum, 0, maximum. And again, if you want to think about rotating negatively, again, you can kind of use that pattern. It begins at 0. It will end at 0. Excuse me, halfway, I would be at the minimum of -1, and I have zeros in between. Okay, so you would have, again, I missed it just a little bit, sorry. Okay, so that gives you, again, 2 full pictures of the cosine curve. And again, to see the whole picture going from maximum to maximum, notice how it takes a full revolution so that we can recognize that our period is 2 pi. Okay? So again, looking kind of at those characteristics, notice it would pass the vertical line test, which makes it a function. Our domain is any real number, any angle measure we can think of. Again, our range is limited in the basic form to -1 to +1. It is periodic. It has that repeating pattern, and it takes 2 pi, or a full revolution around the unit circle, to see the pattern. The cosine curve is even. It is symmetric about the y-axis. Your zeros occur at pi halves and 3 pi halves. So every pi units, you have a 0. Your minimums occur at the odd values of pi. Your relative minimums occur at 0 and 2 pi, or even multiples of pi. And then your y-intercept is at 0, 1. And again, just to kind of help you see, there are real-world applications of the cosine function as well. One of those is brainwaves. And again, you can see, if you're in a deep, dreamless sleep and your brain's not really working, you can see how kind of the curve is stretched out. But if you're awake, normal, and alert and thinking, it's all kind of closer together. And so again, we have to think about how can we transform that basic cosine curve to kind of fit or model the brain waves. And we're going to be talking about that a little bit later. Another application of cosine curves is, again, the idea of the tides, the high tide and low tides, and also think about how high or how low those particular tides might be. But again, at this point, the main thing you need to know and to kind of get really familiar with is the basic shape of the cosine curve in its most basic form, where you start at 0, you start at 1, you end at 1, halfway you're at -1, and zeros in between. You need to be familiar with this basic shape of this blue curve for the cosine.